Alright, so I want to go over some test-taking tips. We're going to start with just going over some computer science, some of the free response questions from a couple years ago, and just to show you how they're scored to give you a better idea of how to get a couple extra points maybe on a test. So you have these guidelines, scoring guidelines, which you're going to get penalties for. So extraneous code that causes a side effect, such as writing to an output, a print where if you weren't specifically told to print, I can almost guarantee you that's not going to happen. Don't print. Failure to compile. Local variables used, but you don't declare them. Destruction of persistent data, that is to say you have a parameter and you mess with it. Void method or constructor that returns a value. Extraneous code with no side effects, you do a precondition check, something like that. You're not going to get a penalty. Spelling case discrepancy where there's no ambiguity, that is to say it's obvious what you meant. You forgot to capitalize a word or something like that. Public or private, you forget, you don't put it in properly. Mathematical operators, if you write these instead of the official Java ones, that's okay. If you use the wrong bracket, equals instead of double equals, as long as it's really obvious. Using length and size for an array list, again, as long as it's obvious. Missing a semicolon provided most of the time you do it. Missing brackets where your indentation clearly shows intent. And missing parentheses in your if or while conditions. And then the scoring guidelines, the test for each point looks like this, and most of them are about 9 points for all the parts. And you're going to get, for instance, in this case, 1 point for accessing all necessary entries and a down list with no bounds error. 3 points for identifying, returning, and matching entry. So you call get title on the downloaded info object correctly. You check for the equality between the title from the list object and the title parameter. Must use the string equality check. All right, it's an object. You got to use dot equals. You can't say equals equals. Another point for returning the reference matching object if present. Null if not. Point not worded for an early return. So if you kick out too early, you're not going to get it. Part B is worth 5 points. 1 point, accesses all entries in the titles with no bound error. 1 point for calling the downloaded info list with the title parameter to determine whether title from the titles list exists in the download. Increments to count matching download info object if it's in the list. Constructing a new downloaded info object with the correct information. Adds constructed object to the end of the list. And then some question-specific penalties, more than your normal ones. You're going to lose 1 if you use get length or size for the array list. Lose 2 in this case if you consistently use incorrect name. And lose 1 if you attempt to return a value from updated download. So let's look at this question. Okay, so here would be the official answer for song list, question number 1. Public download info get song list, string title is the parameter given. 4, using enhanced for loop because you're going all the way through and you don't need to stop in the middle. Download info, go through your download list, create a local parameter called info. If info.getTitle equals the title that I'm looking for as my parameter here, return the info. Otherwise, return null. Part B, the official answer would be to update downloads, give yourself a string, not an array list, but a more simplified one called a list. Which case in point you cannot make an instance of. This is an interface. You can't make an instance of one called titles. For string title, go through my titles list here. Download info found, get downloaded info, get the title. If found info equals null, add it to my list, else decrement the times you've downloaded it, how many times you've gone through. Okay, so we'll look at a couple of these. Sample 1A got all 8 points. Sample D got 4 points. So 1A got all the points. So int k, used a standard for loop instead of an enhanced one, which is fine. Downloaded info compare, so whether k is less than downloaded list size, so we're not going to have a bounds error. Download list compare equals download list get the k. If they equals, so this is a local variable called compare. So if it's the same, if I get the title and it equals my current title, return it, otherwise return null. And then E, which got 4 of the 8 points, wrote a bunch of stuff. Boolean found equals false. For int I equals 0, I is less than download list size, I++, that's fine. If download list get I equals title, return I, not found equals true. If not found equals false, return null. So the problem with that one, or E got 2 points. In part A, the student correctly used the indexed for loop to access all the elements. There is no call to get title in the download list get I, losing the get title rubric point. But returns the comparison with title using equals is correct. Therefore, the returns point is lost because the solution returns an index rather than an object reference. Thus, the solution part earns only the access and equal and title points. Part A earned 2 points. So they got 2 points because they returned, they did a comparison properly using equals against title. Okay, and they got the access without bounds errors, and the equals on title means that they got accesses all necessary entries in the list with no bounds errors. So that was 1 point, and then checks for equality between the title object and the title parameter using string equality as a check, and they did that, so they got the points. And they got 2. Granted, they didn't get 4, but they got, in this question alone, they got half the available points just for doing those 2 things. Okay, so let's go look at another one. Alright. So question 2 is a token pass. Create a token pass object and correctly initialize the game state. Creates an instance variable board. Computes a random number between 1 and 10 inclusive. Random number between 0 and player count -1. Initializes all entries with no bounds errors. Initializes the instance variable current player to computed random value. Question specific penalties. Consistent uses incorrect array name instead of board. And deconstruction of persistent data with the current player. Or attempting to return a value from distribute current player tokens. So just for question 1, the official answer was board equals new int player count. Now board is going to notice it's not initialized here. So it is obviously an instance field from somewhere else in the question. So you'd have to go and, again, make sure you read all parts of a free response question. Look at your instance fields, look at your preconditions, look at your questions, look at everything before you start making things up. Okay? So, no, I don't have that question, but it's right here. Alright, so we're going to make a new board, which is an integer array number of players that we have. For int I equals 0, I is less than player count, I++, board I, fill it with random values between 1 and 10 inclusive. So math.random, cast it to an int, don't forget to ever do that, add 1. Current player equals cast another random value, player count. Now they get the -1 because this is going to round, by casting it to an int, it's going to round it off. Okay, let's look at 2D, because they got 4 of the 8 points. They got half of the points. Alright, so they correctly create an array of player count integers and assigns it to the board variable. They then assign a random integer to the first position, but assigns a copy of that value to all subsequent positions, so they lose that point. The student assigns a random value between 0 and player count -2 on accident. Even though this value is not correct, there is enough of an idea of creating a random number to get a point for initializing the current player. Since both random numbers must be constructed correctly to read a point for random number construction in this problem, the solution did not receive a point for random number creation. They earned 2 points in part A. Okay, so let's look at 2D1. So the question is, write a constructor for the token class. The parameter player count represents the number of players. The constructor should create a board array to contain player count elements and fill the array with random numbers between 1 and 10 inclusive. The constructor should also initialize the instance variable current player to a random player between 0 and player count -1 inclusive. Complete the token pass constructor below. Creates the board, blah, blah, blah. So they give you parameters, and then they write the header, and then here's your space to write it on the page. So we got your player count, so board equals new int player count, so they get that point. They did that correctly. Int random number equals int math random number times 10 plus 1. and then for int x equals 0, x is less than board length, x plus plus, set the x to a random number. So they only do random number one time, and then they add all board values to that one random number instead of making a new random number each time they go through. Current player equals int math random times player count minus 1. So it was actually ended up being minus 2 because they should not have put that part on here. Okay, so that is some quick free response guides. And we'll go to practice exam. So don't forget, again, I've been giving it to you. I haven't really gone through it. Don't forget on the practice exam, or on the actual exam, you will get the, where did it go? Let me go grab it real quick. My quick reference guide. Where did my quick reference guide go? There we go. So, quick reference guide. So you're going to get this on the test. It's going to be sitting next to you. So it's going to remind you, if you want to use anything with objects, if you want to use equals, remember it's a Boolean, and you're going to get it as an object parameter, so don't forget to cast it. And then string to string. The integer class values, min and max, they even tell you what they're for. The double values, and then the important one, string is length, substring, they give it to you, returns a substring, and it even tells you the answer. So you don't have to memorize how to use it. These are going to be on there. Okay, your math, absolute value, power, square root, and random are also given to you. And then the list, size, add, get, set, remove. Remember, this is an interface. Okay, so it works just like the array list, because the array list uses the list class. Okay, so this is class java.util implements the java.util list e interface. Okay, the thing is you will make you can initialize objects of an array list. You cannot initialize an interface, so you can never make a new list. Now, what you can do is you can make a new like a list that's a new array list. Anytime you make an interface, you can sort of use polymorphism to hide it. So I could say something like list string x equals new array list string whatever. Okay, but I cannot initialize a list of I can't initialize a list because it's an interface. Oops. So test taking tips on the multiple choice exam. It's all about not running out of time. Okay? So some of them are smaller than others. Some of them have choices. Some of them are very long. Read, take a second, blow through them all. Figure out which ones you want to do. Okay? So this one's not particularly long, but anyone that has like 1, 2, and 3, those take a while because you got to check everything. Now, when you're going, once you understand what the question says, which of the following test cases we'll call sequential search 5 will always result in an error. And when you go through on some of these, you can go through and you can as soon as you find one that doesn't fit, cross it out. Especially when it's one of those ones which one of these works. If as soon as you find one that doesn't work, cross it out. That way when you go back and start counting your lists, you won't have to reread them. Okay, ones with lots of reading will take a while. Okay, things that you have to trace, especially if there's recursion. If there's anything to do with recursion, skip it, come back. Again, here's another long one. All right, so you read it and you have to trace these 4. Okay, and which of the following will replace your missing code? So you have to trace it and figure out which one works. So you have to read the condition, figure out what this method is even supposed to do, and then trace through. These take a while. Skip it, come back. But remember, you have to answer every question, even if you just guess. If there's a question that's blank, it's wrong. So don't leave anything wrong or blank or empty. But make sure that you don't just run out of time. Go through, find the easy questions. There's going to be some, okay? So here's an example of a list. So we're going to manipulate it. So we're going to do you're going to count down with a standard for loop. We're going to check the substring, move on. You can pretty quickly figure out if it doesn't start right. Cross out. I know it's not that one. I know it's not that one. I know it's not that one. All right. So it's so short circuit. I go through, say I'm looking for. Looks like here's my list. Zebra. Oh, that's not right, or whatever. Knock it out, and then you don't have to worry about reading it over and over and over again. And this one would be another very long one. Requires a lot of reading. Skip it. Come back. Do not run out of time.